Lesson 6.1, Solving Systems of Equations by Graphing. Your objective for this lesson is to solve systems of equations by graphing and to analyze special systems. Okay, example 1, they want you to find the solution to the system of equations here by graphing. The way you do that is you're going to graph two lines, and the point where they cross is your XY solution. So it'll be the numbers that satisfy the X and the Y in the equation. So the first thing I want you to do is put it in slope-intercept form. It's already in slope-intercept form, so you have that taken care of. The second thing I want you to do is to graph them. So for this top equation, your y-intercept is 2, and your slope is 1. So we're going to graph that in pink. Our y-intercept is 2, so we're going to put point on 2 on the y-axis. Slope is 1, so we're going to rise 1, run 1. And now we have our line. And then the second one, we're going to graph in blue. Our y-intercept for this one is -2, and our slope is 3. So we're going to put a point on -2 on the y-axis, and we're going to rise 3, run 1. Rise 3, run 1. And keep on going until your lines cross. Make good long lines so you can see where they cross. And you'll notice that they cross right here at this point, and that is the point 2 on the x-axis and 4 on the y-axis. So the point 2, 4 are my x, y values that satisfy the system. So my answer to the system is 2, 4. All right, guided practice number 2. I want you to use the same graph, and I want you to graph these two lines and tell me your answer. Pause the video to do it and resume it when you're ready. All right, we're going to graph the first line in purple, and the y-intercept for this one is 4. Slope is 2, so we're going to rise 4, put a point, and slope is 2, so we're going to rise 1, run 1, and I run out of graph, so I'm actually going to fall 1, go left 1. You can do it exactly opposite, and you'll know that you're doing it right because your points will line up in a line. Make good long lines. And now the second equation we'll graph in green. Our y-intercept is 2 and our slope is 1. So we're going to put a point on 2 for the y-intercept, and slope is rise 1, run 1. And then I'm going to draw my line. And it looks like they'll cross right here. So I'll do that in black. And that is the point -2, 0. So the answer to this system of equations is -2, 0. All right, example 2. For time's sake, we're going to omit this on the video, but we will do questions like this in class. But for the video and for your outline, you just put omit. All right. First, before we move on to example 3, we want to talk about the different types of systems you can have. You can have a consistent system, which is a system that is either, it has one solution, and then you can classify a consistent system as independent, I should say at least one solution, not just one solution. And you can classify a consistent system as independent or dependent. Okay, an independent system falls underneath the consistent category, but it means it has exactly one solution. A dependent system also falls under the consistent category, and it means it has infinitely many solutions because it's the same line. The lines lay on top of each other when you graph them. And then you also have the opportunity to have an inconsistent system, which has no solution because they don't cross. And what type of lines don't cross? Parallel lines. So if you end up with the same slope and different y-intercepts, you've got parallel lines, which means they do not cross. If you have the same slope and different y-intercepts, same y-intercepts, then what you have is a dependent system because you have the same line. All right, example 3. These are the special types of systems. So what we want to do first is put it in slope-intercept form. The bottom line is in slope-intercept form, but the top line's not, so we're going to have to rewrite that. And I'm just going to completely copy the question. Then I am going to solve for y. So I have to get y by itself. First I'm multiplying by 2, then subtracting x. So the opposite of that would be add x, and we get x plus 2, and then divide by 2. And we get y equals 1/2 x plus 1. So we're going to graph this line in green, and our slope is 1/2, and our y-intercept is 1. So y-intercept of 1 and slope of 1/2 is rise 1, run 2. And then draw a good long line because you want to see where these lines cross. Then the purple one, slope is 1/2, y-intercept is 1. So we're going to go up 1, and then we're going to rise 1, run 2. And what you'll notice is that my lines are actually the same line, which means this is a infinitely many solutions. And if they asked you to classify it, you would say this is a dependent system. All right, B, we're going to use the same graph. We're just going to use different colors to graph on it. Saving paper, saving trees. So for the top one, it's already in slope-intercept form. That's going to have a slope of 2 and a y-intercept of 2. The bottom one's already in slope-intercept form. That's going to have a slope of 2 and a y-intercept of -1. Before you actually put it on the graph paper, I want you to inspect and notice that slope is the same. And the y-intercepts are different. What type of lines have the same slope, different y-intercepts? Parallel lines. If the solution to a system is the point where they cross, and parallel lines never cross, then parallel line system has no solution. I don't have to graph it. All I have to do is look at my slope. All right, guided practice number 3. I want you to graph both of these on the graph and tell me whether it is no solution or infinitely many solutions. Okay? Do it for A and B, and then I'll get back with you with the answer. Alright, so A, the slope of the top one is -1. Y-intercept is -3. B, or the slope of the bottom one is -1, and the y-intercept is 5. Slopes are the same, y-intercepts are different, which means these are parallel lines, so the answer to this one is no solution. For B, you have to put the bottom one in slope-intercept form first, so I'm going to rewrite it. Solve for y, divide both sides by 3. And I'll notice that with the top line and the bottom line are the exact same line. It is indeed the exact same equation. So that means this one has infinitely many solutions. And you don't actually have to graph it. Just if they're different lines, you have to graph it to tell the answer. But if they're the same line like this one, or they're parallel lines like this one, you don't have to graph it. You just look at the slopes and the y-intercepts and say whether there's no solution or infinitely many. Okay, bring this tomorrow for proof that you did your homework and be ready to take a quiz.